And we're back with Professor McSaid. We're talking about the surface area of cylinders. And so when we talk about the surface area of cylinders, it looks a little bit different than the surface area of the prisms. So we have the total surface area here. We're going to find the first one. When you look on your formula chart, it's 2 pi RH plus 2 pi r squared. Now that looks really way more complicated, but it's really not because there's no P or B that we have to find. However, 2 pi r is actually the circumference, or P. Yeah, looks like the total of prisms. And then pi r squared here is or capital B, I guess, is the area of a circle. So this derives from the same thing, just you don't have to find the circumference and the area of that base. It's all right here in the same formula. So all we need to do is identify R and H. So R is going to be 2, that's my radius, and H is the height of the cylinder, which is going to give me 4. All right, so now then just straight plugging that in. So I have 2 times 3.14 times 2 times 4 plus 2 times 3.14 times 2 squared. So I'm using 3.14 approximation for pi on this one. So then I can plug that in and I get 75.36 feet squared. What that's going to tell me is how much, whatever we're covering this cylinder, all top and bottom, we're going to have to use 75.36 square feet of it to cover this whole thing. So maybe, we're talking about maybe a water trough or something like that, because this is in feet. So it's going to be a fairly large cylinder. That's how much, let's say, metal we're going to have to use to cover this whole thing. All right, so then let's look at the second example here. We're just finding lateral this time. And so lateral surface area is 2 pi RH. Again, 2 pi r, that is circumference or perimeter, which is just like this lateral surface area of a prism. So I'm going to need to plug this in. I need to find R and H. R is going to be 8. Remember, just because this is how tall it is, that's not necessarily the H. The H is 5. This is the height. All right, so plug those in. 2 times 3.14 times 8 times 5. Plugging that straight in. I get 251.2 centimeters squared. So what that's going to do is that's going to cover the outside of, let's say this is a can, so it's going to cover the outside of the can or a can label, just the lateral surface area, not including the 2 circles that are the 2 bases, so the top and the bottom. 251.2 centimeters squared. All right, so here we have a cylindrical vase, so it's a little bit of a word problem. That is 10 inches tall, has a diameter of 3 inches. I want to find the surface area of a vase. Now, remember, this is a big hint. The top of a vase is open. It's open. So I need to think about that as I do here. So the first thing I need to do is I need to draw this cylinder so I can kind of sort of see what I'm looking at. All right, and so it is 10 inches tall and 3 inches in diameter. So that's going to give me an R of 1.5. Now, remember, surface area. If I find the total surface area, that's going to be 2 pi RH plus 2 pi r squared. That is including both bases, top and bottom base. We only have one base. So this time, we are not going to do 2 right here. We're just going to add one of the bases. This would be just one of the bases, because remember, our hint says that the top of the vase is open. So if this were glass, we're finding how much glass it's going to take to make this. All right, so then I'm going to plug in my R and H here. So I have 2 times 3.14 times 1.5 times 10 plus 3.14 times 1.5 squared. Plugging that straight in, I'm going to get 101.265 inches squared. So that's going to tell me how much, whatever I'm doing is covering this vase up, is 101.265. So this is what I have for you for the surface area of a cylinder, and Professor McSaid out.